Right now, we'll start with IPC product story. So I'm Mikhail. I'm product manager in IPC team. I joined Protocol Labs a few months ago. And I think IPC is very important for the future of blockchain scaling. And we talk about IPC. When we talk about IPC, we have this concept of planetary scale apps. And a planetary scale app is an application that involves significant percent of Earth's population and become important part of their lives. If you think about it, you can think about like Twitter, TikTok, Telegram, Microsoft Office, Roblox, and others. And our vision of the future is when planetary scale application has the option of being open and have open governance and being decentralized and on-chain. And to make this vision reality, we went through some technical analysis, like what infrastructure is needed to make it come true. And we start thinking about different aspects of blockchain. Can you really build application like Twitter just using decentralized systems that fully auditable and fully kind of follow open governance model? And we start thinking about blockchain limitations. And let's say how many requests per second Twitter serves as about 5 million requests per second. And if you compare it to the throughput of major blockchains, it will be like many orders of magnitude lower. For example, if you think Bitcoin is 7 transactions per second, and like some other blockchains a little bit more, with Solana 65,000, which is like it's a theoretical maximum. It's not actually the real number. So, but this slide shows us that existing generation of decentralized technologies are not capable to deliver applications that truly planetary scale. Second dimension that is interesting is response time. Is if you open Chrome developer tools and see how long does it take to serve Twitter request, it's about 31 milliseconds. And if you compare to blockchains, you see like it's order of magnitude slower, while the difference is not as striking as with like throughput times. A third limitation is limitation regarding data and compute. If you want to store 1 kilobyte of data on Ethereum, it will cost approximately $100. And if you want to store it on AWS, it is like a tiny fraction of a cent. So like it's 1 billion times cheaper to store data on AWS than Ethereum. And of course you think, yes, we are a part of Filecoin ecosystem, and yeah, like if huge data that is available on Filecoin can be accessible in a transactional sense to smart contracts, that will be a huge win, and then this equation will change dramatically. But before that happened, it's not possible to create compute type logic that is part of your applications that can process large data model on decentralized system. And size of the algorithm is another limitation. Like Ethereum smart contract or EVM is maximum size is 24 kilobytes. If you take Twitter search algorithm is about 7 megabytes. So like again, we are orders of magnitude away from being able to build this real-time applications. No, sorry, planetary scale applications. So we see IPC as a solution to this, to break this limitation and make planetary scale application possible. So you can see our like a long definition, and you can read it. I'm not going to read it out, but I want to point out few important aspects. That IPC is decentralized and trustless protocol. That it is built to enable planetary scale Web3 applications, and we want to support a wide range of applications that kind of be a part of consumers' lives, like social networks, multiplayer games, AI, productivity, and others. So it's not just some DeFi application, it's applications that you use on your phone or on your computer every day. And Another aspect that we want to work on, we want to achieve Web2 type of volumes with millions transactions per second and high throughputs, sub-second latencies, and build it all in a decentralized architecture. Okay, I'll talk about 4 aspects of our solution, how it works. And it starts first with scalable protocol. So if you heard about IPC before, you know that IPC creates a tree of networks. So you have, for example, Bayonet, which is layer 1. You can have different subnet for different reasons. For example, you can have special L2 for gaming that is a parent of multiple games. And one game can have subchains for some particular purposes. Or you can have different L2. Here it's focused on databases and so on and so on. So instead of creating one big chain to rule them all, we create a tree of chains. And it creates this scalable architecture. And when I say scalable, I mean high throughput. So instead of running one consensus algorithm in L1, or maybe with overflow L2, like in Ethereum, you can think about Arbitrum or Optimism, we create like a lot of chains. So like you can parallelize computations by creating additional chains. And since multiple consensus algorithms run in parallel, the throughput can grow linearly. Another interesting aspect is regional subchains. So if you want enforce data locality laws and low latency, if you want the latencies like lower than 1 second and maybe down to like 100 milliseconds or even 10 milliseconds, you need to place your nodes much closer to each other. So you can have, in this model, you can have specific subchains that will be optimized for low latency scenarios. For example, imagine you building a game. Let's say it's a fast action game like Call of Duty. You will put it under the gaming subnet, but in each local region, let's say US, European Union, and Asia, or like you can have more obviously, and you can have a specific subnets for this geographical region to achieve, again, data locality loss and low latency. Another aspect, you can build custom subchains, like you can change your consensus protocol, you can create storage-heavy subchains, compute-heavy subchains. So when you can change the way your blockchain works depending on your use case. Okay, second option, I'll go a little bit faster because we are running out of time, because we started a little bit later. So second aspect is flexible runtime. So besides the protocol itself, you need a stack, a runtime that is the base of your node software. And it's another part of the innovations that goes into IPC project. I think Alfonso was talking about it yesterday. It's called yellow runtime. And the idea, I'm not going to go too deep into this because we had a separate presentation, but the idea that like flexible runtime that treats code as data, it can receive code updates through the blockchain transaction. It's much easier to change what your stack does and upgrade it on the way. So like you can upgrade your software very easily. You can customize your node behavior, and you can change your blockchain stack on a go essentially, because like you can just change the payload. Another aspect, since this runtime is a part of FVM virtual machine, which is WASM based, another aspect, you can extend your blockchain not just to the core, but to the clients as well. So like if your blockchain validator node can be a part of, like run in your essentially web browser, your client nodes doesn't need gateway anymore. They speak directly the consensus protocol instead of kind of being outside of the chain of trust and calling some API gateway to get data from the chain. So when we thought about how we're going to build this developer ecosystem, how we're going to allow developers to build this planetary style applications, we understood we need to change the way how applications are built. Because, for example, Web 2 has already a a number of primitives that developers use when they deploy the applications or when they build the application. For example, they have containers, they have like serverless cloud functions, they have databases, they have storage buckets, and others. So like when you build application in decentralized world, you need to create another set of primitives that covers the same set of use cases. So we don't have answer for this, but it's more like a statement of intent. So to make sure that it is possible to build planetary size application, we will create a set of decentralized primitives. And maybe they will be similar to what people have in Web 2, and coding for blockchain will be very similar to coding for traditional centralized infrastructure, but maybe they will be different. For example, like will database run on chain, or you will use something different like agent architecture when you need to store a code with your data, and it's easier to do and high performance from consensus perspective. That question is open. But the idea here is that we will create this set of developer primitives that will streamline creation of the application for decentralized apps. The last part is ecosystem of services. So when we talk to some of the builders and we ask, like, why do you want to build in Filecoin ecosystem? Why do you want to use IPC as their protocol? They were saying, like, you know, like we really like where this whole ecosystem is going. For example, like we were talking with one team that they were building digital ads platform, and they were saying like, oh, if we build decentralized system, we need some primitive like compute over data, because they want to run their machine learning models, inference, like in a decentralized way. So we see it as a strong kind of side of our product that Filecoin ecosystem invest into this fundamental building blocks of applications like storage, like compute over data, like databases, and it will essentially make easier for developers when they come to ecosystem and try to implement these large applications. They can use existing components and existing infrastructure rather than just reinventing the wheel and building everything from scratch. So then there is a question like, okay, we build this IPC stack, like how do you start? So we plan to create general purpose level 2 subnet for Filecoin mainnet. The code name is Mycelium. And the idea behind it is to make a fast and cheap reference network as a starting point for development. So if you think about it, like if we don't build this L2, like what's going to happen? Then as a developer, you need to download the stack, you need to find hardware, you need to run your own chain, you need to connect it to mainnet, and it's possible, it's a part of our developer experience, but it's not frictionless, right? Like there is a lot of homework you need to do before you can start deploying smart contracts. So many developers are asking us, like, can we start using IPC? Can we start having faster and cheaper blockchain in Filecoin ecosystem that can still talk to mainnet, but without managing our own infrastructure? So the answer is, like, we will build this general purpose L2, and we invite all community members. If you want to run a node of this network and become a validator, please let us know. We will be happy to, if you join. We want as many partners as possible, because the more decentralized this network is, the more secure it is. So yeah, we plan to rely on community effort. Another idea behind it, that like we would like to deploy some production network that everybody will use or a lot of people will use. This way we will prove that stack is mature enough, and if there's any bugs, we can be able to remove them much quicker if we work like through the partners. So yeah, so Mycelium will be a starting point for many developers to kind of to start dipping their toes into Filecoin scaling ecosystem, but it's by no means like the only L2s are going to happen. Like anybody can take off-the-shelf IPC stack and run their own L2. We encourage people to do it. So if we are not trying to compete with developers, we want to provide a consistent reference starting point, how IPC network can look like, and we encourage everybody to do the same.